9.2, intersections, unions, and compound inequalities. The first example we'll do will be this one, where notice this sign. This sign implies union. So remember, what does union mean? Union means a combination of the elements of all of the set. So we just combine everything. There is a repetition. We don't write that element more than once. So in this case, we're basically going to take all the elements of this first set and all the elements of this. If there's any repeated elements, we won't write them more than once. So let's see, what does that give us? Now remember, we're creating a new set, so it has to be written properly. So we'll go ahead and write the open curly parentheses. So I can go ahead and write all of these. Order doesn't really matter here, so you don't have to worry about order. So we have A, B, C, D, E, F, G. Now the A we already got, so we can throw in the E, or sorry, we already had an E as well. We don't have an I, an O, or a U. So this is the union of these two sets. Now in the second example, we want to do an intersection. This symbol represents intersection. An intersection means all elements that they have in common. So what do they both have in common? We see that they both have a 2 in common, and they both have a 4 in common. So the intersection of these two sets will be the set with elements 2, 4. Okay, this next example. Now this is what we call a compound inequality. Basically, we have more than one inequality. And when you have it written like this is basically an intersection. You can really look at this as two pieces. I can write that down on the side. It's basically saying -2 is less than or equal to m plus 3, and that's the intersection. M plus 3 is less than or equal to 6. So remember, with the intersection, we want everything that they have in common. But because the m plus 3 is common in both, we were able to write it like this. So we do the same thing. We still want to isolate the m. Now, to isolate the m, whatever we do to isolate the m, we have to do to all three parts. In this case, we need to subtract 3. So we'll do that in all the parts. So we have -2 minus 3 is less than or equal to m plus 3 minus 3 is less than or equal to 6 minus 3. So notice we did -3. We have to maintain the balance. So that gives us -5 is less than or equal to m is less than or equal to 3. And we can just go ahead and graph this on a number line. Okay, so here's 0 somewhere. I can say -5 is here, and 3 is somewhere here. So we want all m values, if we read in terms of m, kind of going backwards, we want all m values that are greater than or equal to -5. So that means we want everything greater than -5 to the right of -5, and we want to include the -5, so we'll have brackets. And then we also want all m values that are less than or equal to 3. So to the left of 3, and we will also use brackets because it's included. So this would be our solution graphed. Okay, now in this one, notice the key word. The key word here is or. Or implies a union. So we'll go ahead and solve each inequality. We can go ahead and graph each one on the same number line, and our solution will basically be a combination of everything that gets graphed. So in this one, we need to go ahead and isolate the 3a by adding 7 both sides. So we have 3a minus 7 plus 7 is greater than -10 plus 7. That gives us 3a is greater than -3. So now notice here, even though this number is a negative, we're not actually dividing by a negative. We're going to divide both sides by 3. So the sign does not change. So we have a is greater than -1, or let's go ahead and do this. We'll subtract 2 both sides. 5a plus 2 minus 2 is less than or equal to 22 minus 2. That gives us 5a is less than or equal to 20. So we have a is less than or equal to 4. So let's see if we can graph this on a number line. I ran out a little bit of room, but we can do this here. So -1. So let's say here's 0, here's -1, and I want 4. So I want every number that is greater than -1. Now remember, this is a union, okay? So I want every number greater than -1, not including the 1. Do that in green. So I'm going to shade all of this and put parentheses. Now I'll use a different color. Or actually, I'll use the same color, but I'll just do it on top. Now I want every number that is less than or equal to 4. So that would mean starting at 4, or that will be our endpoint, and going to the left. Now, because we had a union, that basically means you want to combine everything. So if you take all the shading of the first inequality and all the shading of the second equality, what is shaded in total? Well, you can see pretty much the entire number line gets shaded, right? The a is less than or equal to 4 basically gives us shading going all the way to -infinity, and the a is greater than -1 gives us shading going all the way to +infinity. So our solution here is from -infinity to +infinity, or we can just write all real numbers. Okay, let's try this one. So now in this one, notice our keyword is and, which is an intersection. So now we can shade each one of these once we solve them, and we will find the overlap. So let's go ahead and do this one. So we will add 1 both sides. That gives us 2x is greater than 6. X is greater than 3. And in this one, we'll divide -2 both sides. Notice here we are dividing by a negative on both sides, so the sign will flip. We have x is less than 3. Let's go ahead and draw our number line. Now 3 is here. So for this first one, I want every number greater than 3. So that will be to the right of 3. And I'll put parentheses because the 3 is not included. Now, let me use a different color because here we're looking for an overlap. I want every number less than 3. So that'll be everything to the left of 3 and parentheses. Now remember, the intersection asked us to find everything that they have in common. So the question here is, what do they have in common? Well, we can clearly see that there's no overlap in green or purple in either one of these. So the question now is, what's going on in 3? Is the 3 common? Well, the 3 is not used here, and it's not used here, so it obviously can't be used here. So nothing is in common. So if there's nothing in common, our solution is the empty set. So remember, the empty set we would write either as this symbol, or we can write the curly parentheses but nothing inside to show that we have an empty set.